thank you for this nice introduction, and now we can start to talk about industrial microplastics and pellet loss, status quo and possible reduction measures. And the results are funded by the Federal Ministry of Education and Research and are parts of our recent project, EMI Stop. So if you look for that, you will find more to it. So what are pellets? Pellets are, or nurdles, or granules, as you can say, are intermediate particles and materials, so mostly virgin plastics or master batches. And they have this really specific shape, which you can say, okay, this is a pellet or granule or nurdle, so it comes from an industrial site or comes out of the production chain of plastics products. So as we started, you could find these pellets outside of producing facilities, as this picture shows. You could find them in the inlet of wastewater treatment plants and also in the environment and on riversides and so on. So because of this specific shape, you could tell, okay, this must have come from the production chain of microplastic products. So then we ask ourselves, okay, where did the microplastics occur at industrial sites? That's why we did a Delphi survey, and we interviewed 43 site operators and industrial representatives and asked them questions about it. And they said about their microplastic losses, yes, we can see them at our site. So over half of them said, yes, they are visible or significant. And also, the fate of the microplastics as industrial sites are in the wastewater, the rainwater, and the solid waste disposal. So these are the main things from the perspective of the site operators. So then we did site inspections, and there we saw 4 major hotspots. So we had outdoor storages at some sites, we had waste management, which was outside. We had traffic areas where we could already see the pellets on the ground, and also loading or unloading zones, independent if it was octabin or a tank or like a sackware. So after that we said, okay, we can conclude out of it. We have indoor processes, so we have there a controlled environment. We have a wastewater system, we have waste management, which is working quite good, and also we have air cleaning. So indoor processes are mostly very controlled, so we didn't see a lot of concern there. But in outdoor processes, in the production, we have possible control releases, as we just saw in the hotspots. So we called the group of Professor Barkmann-Metaj and asked, okay, which brim did you use? And also did sweeping analysis at some sampling sites. And I just wanted to make sure that you understand all these sites we contacted and where we did our sampling are in one of the initiatives from industries. So Operation Clean Sweep, Zero Pellet Loss, or Alliance to Combat Plastic Waste, all these initiatives. So all the results come from sites which say, yes, we are in one of these, and yes, our systems we implied from these initiatives, they're working. But regarding, we found microplastics, so pellets, on the ground, on waste container sites and loading or unloading zones. There were the most particles on the ground, like over 10 grams per square meter for waste containers. So these were the 2 main hotspots we identified also with sampling. And then we looked at the estimations we found already, and the recent estimation from Conversio also says, okay, we have pellet loss of over 400 tons per year, and it's also during processing and transport mainly. So they also see transportation as the highest emission potential, and also loading and unloading activities. And which is also interesting is that also these estimations say, yes, we have to look at drainage systems and wastewater and stormwater. And that's why we asked also our participants in our survey, okay, what's with your stormwater disposal? What's happening? And there we saw an interesting result, because most of them said, yes, we treat it together with our wastewater, but there were a concerning amount of participants who said, no, we direct discharge our storm and rainwater without pre-treatment into the environment. And that's what's of high concern for us, because we saw in the pictures we have a lot of pellets and microplastics on the ground, which can go with the storm and rainwater directly into the environment at these facilities. So we look now at the pathways into the environment. So we have our unintentional release, which is happening every day. It's not like an accident, it's one of the processes we do daily at these sites. So there we have pellet loss or plastics waste, which can go into air, soil, or water body compartments. So this can be a diffuse emission, which we didn't measure, but that would be really interesting to look at in further detail, especially at industrial sites. And this could be drifting, erosion, or fragmentation. Then we have our wastewater and also our storm or rainwater. And there, of course, we also have tire abrasion, because we have a lot of transportation activity going on, especially at industrial sites. So now we have to ask ourselves, okay, what barriers do we have? How can we prevent these unintentional releases? And there we have to address that, first of all, we can do technical and organizational measures to prevent these unintentional releases so that we don't have to deal with them afterwards. Then, of course, we can do pre-treatment for wastewater and stormwater before it goes into the sewage system. And at the last barrier, we have our wastewater treatment plants, municipal or industrial, depending on the industrial site we're looking at. And they already have high capacity of or high removal rates for microplastic pellets. Yeah, and these are the pathways and the barriers we have to look at, and now my colleague will present to you in further detail the reduction methods and these barriers.
Like Luisa said, in usual we distinguish between technical and organizational measures, but always a combination of both would be the best way to do. The technical measures are mainly based on approved and available technologies from wastewater treatment or constructive measures. They are likely to be more effective than organizational ones, and a further advantage is that they can be combined with other purposes of wastewater treatment. Organizational measures depend on the employees' acceptance and therefore need some monitoring by the management. So they are assumed to be less effective than the technical ones. And further disadvantage is they are often single-purpose solution for pellet loss reduction or microplastic reduction. The technologies that are useful for pellet loss reduction or microplastic reduction in wastewater streams are well-known technologies from wastewater treatment. So we recommend pre-treatment of wastewater in cases of indirect discharge of wastewater in municipal wastewater treatment plants or bigger industrial treatment plants, and we recommend technologies like sand filtration, flotation, chamber filter presses, and all these technologies are well known. So we have them and we can use them. The same technologies or similar technologies can be applied to treat stormwater or rainwater. But in some cases, it might be not possible to have this stormwater pre-treatment or stormwater treatment. And in these cases, it might be very good to discharge the stormwater into municipal wastewater treatment plants or into industrial wastewater treatment plants. We know that those measures are very effective because we did a lot of research on several industrial sites. We investigated plastic production plants, plastic logistic plants, etc., and even big industrial parks in Germany. Besides, this is my current project, we investigated non-plastic production facilities like paper mills. As you can see, the concentrations of microplastics are very high in the raw wastewater. But the a pre-treatment of this raw wastewater can reduce the microplastic concentrations about 90 to 99%. A further treatment in biological wastewater treatment even reduces the microplastic concentration about another 99%. And if we use sand filtration, etc., in cases of the third wastewater treatment in municipal wastewater treatment plants, we have another 99% microplastic reduction if we use available technologies. So we come to the conclusion that industrial wastewater treatment plants are no significant hotspot for microplastic emissions. The concentrations in the wastewater, treated wastewater, are just a bit higher than in municipal wastewater, and we don't see any pellets in the effluents of wastewater treatment plants. Most of the microplastics in treated wastewater are below 15 microns. So we can assume that there is a 100%, more or less, reduction rate for pellets in wastewater treatment. But in some cases, wastewater treatment, wastewater pre-treatment, or stormwater treatment may not be possible. In these cases, other technical measures are a very good solution. Most of them are based on constructive solutions. So if you want to prevent to expose your floor to rainwater, it might be very sufficient to do roofing or housing of those loading areas, storage areas, etc. So if there is no rainwater, you don't have to treat it, and there is no emission potential through rainwater. Other technical measures may be the improvement of packaging or storage. Additional, or in cases technical measures aren't possible, organizational reduction measures are a very good way to go. And as said, they might be not that effective, but they can be. I will come to this later. Those organizational measures are very individual for each industrial site. Each industrial site has different standard operating procedures, different employees training, etc. And this is where to go to. We have to train the employees to get sensibilized for microplastic losses, and we have to change standard operating procedures. And this might not be easy in the industry. Some organizational measures that might be good for all industrial sectors are the cleaning of vehicles. For example, truck tires that are an emission pathway from the industrial site on streets and therefore in the environment. We also can clean production equipment and storage or filling stations. Those measures can be very effective, as you can see in the picture below. These are bagging hoppers that are used to fill pellets into sacks. And those bagging hoppers are stored outside on an industrial facility and exposed to rainwater. And we implemented a way of pre-cleaning those bagging hoppers before the storage outside the facility plants. And as you can see, the pellet loss potential. Bitte? Oh, I can see it, but you can't, I guess. The potential of pellet loss gets reduced about 99%. But it depends on the employee's acceptance. You have to monitor your employees to clean those bagging hoppers. And maybe, as you know, this isn't easy in the daily life. So I repeat my conclusions. They are mainly the same conclusions as I told you before. Stormwater must be considered as one of the main emission paths for pellets into the environment. But we have the technologies to reduce them. If we treat our wastewater, if we treat our stormwater, we can reduce the emissions to a very, very large amount. But we need further research on microplastics from industrial sites. Like I said, we have a quite good knowledge about microplastics in wastewater and stormwater, etc., but we don't have any knowledge about air or soils or other diffuse emissions that we observed at our investigations, but weren't able to investigate in detail. So I thank for your audience, and if you're interested in this topic, some further literature is available in the internet. Thank you.